This one is C4H8O2. It has one double bond equivalent. Looking at the groupings, we see a 1H in the 9 to 10 region. It's a triple peak. That's fairly likely to be an aldehyde type grouping. Whoops. And you can see that that's where those will appear in 9 to 10. The other clue it's an aldehyde and not, say, a carboxylic acid is the fact that it's a triple peak. OHs are always single peaks and they're generally broad as well. But this is a triple peak in that region, so that's definitely going to be an aldehyde. The other groupings, we've got a CH2 and a CH2, that's two CH2 groups, and we have a CH3. Left over here, we've got one oxygen, so I'll put that in as well, and that should be all the pieces. Now we have to put this together in a way that makes sense. And what you'll notice here is that we can get some clues as to positioning relative to the oxygen by looking at what's around 4 ppm. Now what we find is that around 4 ppm we expect to see things that are like CHs connected to O's. So what we have here are basically our two CH2 groups connected to the oxygen. Now we've got to figure out what's connected in turn to those. But it's going to be fairly obvious from this point here that the CH2 group on this side is going to be this one because it has 4 peaks, so it has to be next to a CH3. This CH2 has to be next to the aldehyde group because it's got double peak, which means it's adjacent to one hydrogen. That would be the aldehyde hydrogen right here. The aldehyde hydrogen in turn has 3 peaks, which means it's adjacent to 2 hydrogens, so it's next to this CH2. So that should be our final structure.